So students, let us see one more observation. You know this equation del cross h bar is equal to sigma e bar plus epsilon dou e bar by dou t. Actually this is j bar is equal to sigma e bar. Then this is dou d bar by dou t. So d bar is equal to epsilon e. We know that one. So this is in time domain. In phasor domain, so in phasor domain, del cross hs is equal to sigma es bar plus dou by dou t is actually j omega. So j omega epsilon es bar. Now this is called as a conduction current density in steady state. This is displacement current density in steady state. Sum of them gives total current density in the steady state. Now here JCS is equal to sigma ES. If I take mod of this and here mod is taken because this is already real. Similarly, JDS is equal to here j omega epsilon es bar, and if you take modulus of JDS, and here modulus of this is omega epsilon and modulus of es bar. If you see carefully, the phase of this one is same, but j comes here. J means e power j pi by 2, that is 90 degrees. What I am telling is j is equal to e power j pi by 2. That means phase is 90 degrees. This is nothing but cos pi by 2 plus j sin pi by 2, like e power j theta expansion. This is 0. So this is j into 1, that is j. Okay. Now, if I take JCS on the horizontal line, horizontal axis, then for example this JCS here sigma ES. So I am writing here JCS is equal to sigma into ES bar. Okay. Now this JCS has electric field and JDS also has electric field. So whatever phase is there here in electric field, same phase is there. Now sigma no phase, that is real term, omega epsilon real term. Now only difference is this phase same, electric field phase here whatever it might be, same phase is present here also, but the phase difference will be here 90 degrees is there for this extra. So if JCS is horizontal, then JDS should be 90 degrees to this one, like this, 90 degrees. So this is JDS. So JCS and JDS, this magnitude and that magnitude, they differ by 90 degrees actually. So the magnitude of this is this one, but in terms of phase difference, if you see 90 degrees. Now this is called magnitude of the total current density. If you draw a line parallel to this one here, like this one parallel to this becomes JDS. Okay. Now of course this becomes JCS, parallel to this one. Now let us definitely some angle is there here. Let us call that angle as theta. ये कुछ angle है इधर, उसको हम लोग theta करके बुलाएंगे. Now let us take tan theta. So tan theta is equal to this one, opposite divided by adjacent. Now that is equal to Modulus of JCS is this one, sigma into divided by modulus of JDS is omega epsilon modulus of ES. That is nothing but sigma by omega epsilon. So here, if you see carefully, if sigma 0, then sigma 0 means loss is not present. Then tan theta is equal to 0. Sigma 0, then tan theta is equal to 0. That implies theta is equal to 0. So that means sigma 0 means lossless it is. If sigma is equal to infinity, then tan theta is equal to infinity. That implies theta is equal to pi by 2. So what is the conclusion? So this is a complete loss. This is actually sigma infinity means complete loss is there. In that case, angle value is very high. Now the conclusion is sigma 0, loss is 0, angle is 0. Sigma infinity, loss is very high and angle is also very high. The meaning is that if sigma increases, loss increases, then angle value is also increasing. That means loss can be represented in terms of sigmas also. Loss can be represented in terms of theta also. Loss can be represented in terms of tan theta also. So now that is why this tan theta represents the loss. It is called as loss tangent. Okay. Now after discussing this much, no need to practice this at home. Now I am writing the highlights which are to be remembered from this discussion. क्या याद रखना है ये डिस्कशन से, ये अभी नोट में लिख रहा हूँ, सब लोग ये याद रखना है. फर्स्ट पॉइंट, लॉस tangent. Actually tan is called as tan, full name is tangent. It represents loss, that is why it is called loss tangent. Loss tangent is defined as tan theta is equal to modulus of JCS divided by modulus of JDS, that is equal to sigma by omega epsilon. This is first point which you have to remember. Then second point, here no, this is JDS. This JDS is ahead of JTS. ये JDS है, JTS से आगे है वो. That is why you call this as leading by theta angle. So JDS leads JTS by theta angle. Here, okay, I will write that later on. Here, JDS leads, that means displacement current density leads total current density JTS by theta angle. This is also statement, student. In multi-select questions, na, option A, tan theta is loss tangent is this one, and second option, displacement current density leads total current density by theta angle. So that is also correct. Whatever we are writing here, all are correct statements. Okay. Now here, third one I am writing. Already we have proved that tan 2 theta eta is equal to sigma by omega epsilon. We have proved this one. This is the theta eta means angle of impedance. This already we know. And from this one, tan theta is equal to sigma by omega epsilon. This one and this one both are equal. So from these two equations, let us say this is equation 1, let us say this is equation 2. So from here we have proved tan theta is sigma by omega epsilon. Earlier we have proved this one. So from equation 1 comma 2, tan 2 theta eta is equal to tan theta. Now you compare both of them. So you get theta is equal to 2 times theta eta. So this is the relation between theta and 2 theta eta. Now what is theta here actually? Theta is loss tangent angle. Tan theta is loss tangent. In that, what angle is the theta? That is called loss tangent angle. Next, theta eta is the angle of intrinsic impedance. Angle of intrinsic impedance or phase difference between E and H. These things you have to remember. Okay. Fourth point, friends. For lossless medium sigma 0 and epsilon is real. In this case, we get del cross h bar is equal to j omega epsilon es bar. We get del cross hs bar because we have seen for lossless medium sigma 0, in that equation if we substitute a j0 sigma 0, then del cross h is equal to sigma e, that becomes 0 because sigma 0 plus j omega epsilon es bar. For lossy medium, that means loss is present, sigma not 0 and epsilon is complex. My dear students, in any medium sigma not 0 or epsilon is complex, that is one case. In any medium sigma 0 and epsilon is real, that is second case. In any medium sigma 0 but epsilon is complex, or otherwise in any medium epsilon is real, sigma not 0, all cases goes to the lossy medium. So anyway, in any medium sigma is not 0 and epsilon is complex. Actually, this is material science concept. Whenever you send a very high frequency into the material, then that material at high frequencies it gives complex permittivity. Same material at low frequency gives or otherwise offers real permittivity. So once again I am telling, if you send any signal with less frequency, then if that signal passes through the material, then that material offers a real permittivity. In the same material, if you apply very high frequency signal, if you send very high frequency signal, then that material offers a complex permittivity. That is material science concept actually. Okay. Now here for lossy medium sigma not 0 and epsilon is complex. Now if I write the equation here, del cross hs bar is equal to sigma e plus j omega epsilon es bar. Previously also written this equation. Now let us try to write this similar to this one. Now what happens if I try to write this one similar to this? Es bar you common here, then this es bar came. Now here you pull out the j omega. Okay, if you pull out the j omega from this j omega, already es came out, then it becomes a epsilon is there. Okay, you can pull out j omega epsilon also, no problem. You pull out j omega epsilon, then it becomes a sigma by j omega epsilon plus 1. Es bar came out, j omega epsilon is pulled out. Now sigma divided by j omega epsilon plus 1. I am rewriting that here. और एक बार लिख रहा हूं इधर. Del cross hs bar is equal to j omega epsilon 1 minus of j. This is 1 by j is minus j sigma by omega epsilon into Es bar. So for example, I will call this as a equation number 3. I will call this as equation number 4. So for lossless medium, this is the equation del cross Hs. For lossy medium, this is the equation. Now you compare them, del cross Hs, del cross Hs, Es, Es. Then here j omega, here also j omega. Here in place of epsilon is there here, but in place of epsilon here, epsilon multiplied with some complex quantity is there. So that is why it is called as a, this one is called as a total, this one is called as a epsilon star. Here epsilon star means complex permittivity. So this is defined as epsilon star, given new name to that. So del cross Hs is equal to j omega epsilon star Es bar, where epsilon star is equal to epsilon into 1 minus j sigma by omega epsilon, and this is nothing but if you multiply this epsilon minus j sigma by this epsilon cancel denominator and multiplied, so sigma by omega you get. And also students, this is the equation of that, but epsilon star is defined as epsilon dash minus j epsilon double dash. It is a definition actually. Now compare these two. So this is equation number 5. So this is the epsilon star is defined as real and imaginary. So this is real and this is real and this one is imaginary. So compare 5 and 6. First of all, I will write names here. Epsilon star is called, epsilon means permittivity, star means complex. So complex permittivity. Epsilon dash is real permittivity. Epsilon double dash is imaginary permittivity. Now you compare 6 and 5. So compare 6 and 5. Dear students, once again I am telling, this formula came from the derivation, but this is the definition because it is a complex. Complex has real and imaginary. Real is given symbol as epsilon dash. Imaginary permittivity is given symbol as epsilon double dash. Complex permittivity is given symbol as epsilon star. There are symbols given. Now compare this one with this equation. So epsilon dash is equal to epsilon and epsilon double dash is equal to sigma by omega. Now loss tangent is defined as tan theta is equal to epsilon double dash by epsilon dash. If you see here, this is sigma by omega divided by epsilon, that is nothing but sigma by omega epsilon. In previous case also we got loss tangent like this. Actually what is going on here? Anyway, I will write here once again. Loss tangent is equal to epsilon double dash divided by epsilon dash sigma by omega epsilon. Why I am putting this in the box now? In the examination, if they give real permittivity and imaginary permittivity, take the ratio of imaginary permittivity and the real permittivity. For example, this is given 6, this is given 2. 6 by 2 gives a loss tangent. In some other question, they give sigma value, omega value and epsilon value. From this formula, you can calculate this one. That means there are two formulas for the calculation of loss tangent. Already I wrote theta. What is theta? Loss tangent angle. There I wrote. So in observation, I did some mathematics. Don't bother about that one. In the note, whatever I have written, so here this is not in the box. That means don't bother about that one. In the note, no, wherever box is there, you have to learn them. These things you have to learn. Okay. So dear students, now it is case 4. Wave propagation in good conductor. For good conductor, sigma not 0 and sigma by omega epsilon ratio will be much greater than 1. So if you want rough calculation, I will do here. You see here. For a good conductor, sigma is approximately 10 to the power 7. Now if I am sending a radio mirchi signal through the good conductor, for radio mirchi signal 98.3 megahertz. So I told you this is approximately 100. You get approximate value 10 power 8. Now sigma by omega epsilon, sigma is 10 power 7 divided by 2 pi f 10 to the power 8. Epsilon is 1 by 36 pi 10 to the power minus 9. So this you get 18, and then 10 power 7 here 10. So 10 power 8 approximately 10 power 8. So it is very high. So that is what written there. Okay. Now for a good conductor, sigma by omega epsilon value is very high. You use this condition in the derivations. Then whatever equations you get, those equations are applicable for the good conductor. You take the general equation and try to substitute this condition in that, then you get one equation. Then that equation is valid for good conductor. Now, what is the general equation of gamma? J omega mu sigma plus j omega epsilon. So this one. Now this is equal to j omega mu. Okay, and you pull out j omega epsilon. The calculation which we have done in last case, same calculation. So sigma by j omega epsilon plus 1 total under root. Now this becomes gamma is equal to, so j omega root mu epsilon, and this is 1 minus j sigma by omega epsilon whole power half. So here sigma by omega epsilon much greater than 1. This sigma by omega epsilon is actually imaginary part, 1 is real part. So imaginary part is much greater than real part means you can neglect the real part. That is the meaning of that one. As sigma by omega epsilon is much greater than 1 for good conductor, neglect 1. That means real part, that is neglect real part. You can neglect real part for conductor. So this is general equation, that means applicable for all mediums. Now for a good conductor, this condition is valid. That means 1 is real part, this is imaginary part. So 1 is neglected. Now real part is neglected. Now let us see what equation we get. So gamma is equal to j omega root mu epsilon and minus j sigma by omega epsilon whole power half. Now here students, I am writing J is equal to e power j pi by 2, that you know. Minus j means e power minus j pi by 2. If you want, you can write here e power j pi by 2 is equal to cos pi by 2 plus j sin pi by 2. So that gives plus j. Similarly, e power minus j pi by 2 means cos of minus pi by 2 plus j sin minus pi by 2. You get minus 1 into j minus j you get. Okay. And similarly, you remember these things also, e power j0 and minus 1 means e power plus or minus j pi. Okay. So this is cos 0 plus j sin 0 is 1. E power plus or minus j means cos pi plus or minus j sin pi. Then sin pi is 0. So cos pi is minus 1. So these are standard things. We are going to use them. Now anyway, here minus j is e power minus j pi by 2. So that is equal to j omega root mu epsilon. Minus j means e power minus j pi by 2 sigma by omega epsilon whole power half. So this is equal to j omega root mu epsilon e power minus j pi by 4 and root of sigma by omega epsilon. Now gamma is equal to j omega root mu epsilon. Inside root here sigma by omega epsilon is there. Okay. Next cos pi by 4, that is 1 by root 2, minus j sin by 4, that is 1 by root 2. So you multiply this one, that is gamma is equal to here omega and this one. Anyway, here epsilon cancel. Ultimately, you get j into j square is minus 1, minus into minus plus. So plus, and here 1 omega remains, then mu remains, then sigma remains. Here root 2 means 2 came, root. Now j plus j omega mu sigma divided by 2 under root. So this is equal to alpha plus j beta, and conclusion is alpha is equal to beta is equal to omega mu sigma by 2, that is nothing but you write 2 pi f, so root of pi f mu sigma. So dear students, what is your observation? For good conductor, alpha is present, beta is also present, and both are equal. Both are equal. Now, I already told you that skin depth is equal to definition is 1 by alpha. This is the definition. So this is a definition of skin depth. So for good conductor, del is equal to 1 by alpha, that implies del is equal to 1 by root pi f mu sigma. Okay, if you want, you can remember this also. So where del is skin depth. I told you for a good conductor, sigma is very high. This will be in micrometers. Micrometer means very small thickness. That is why it is called skin. Skin means very, very thin. That is the meaning of that. Now, second calculation, impedance calculation, that is j omega mu divided by sigma plus j omega epsilon. That is equal to j omega mu divided by j omega epsilon and sigma by j omega epsilon plus 1. Okay, this cancel, root mu by epsilon divided by 1 minus j sigma by omega epsilon whole power half. So ultimately eta is equal to root mu by epsilon 1 minus j sigma by omega epsilon whole power minus half, students. So this is a general equation. Simply we have done some mathematics here. For a good conductor, sigma by omega epsilon is much greater than 1. So neglect 1 compared to this one. Then you get root mu by epsilon, then 1 is neglected, minus j sigma by omega epsilon whole power minus half, that is equal to root mu by epsilon. Minus j is written as e power minus j pi by 2 and sigma by omega epsilon whole power minus half. So eta is equal to, this one is a root mu by epsilon. Then here sigma by omega epsilon whole power minus half means it is inside root and reciprocal you have to take. That means omega epsilon by sigma, here this one. Then this is e power minus j pi by 2 whole power minus half means e power plus j pi by 4 you get. So then cos pi by 4, that is 1 by root 2 plus j sin pi by 4, that is once again 1 by root 2. Now this one becomes epsilon cancel, omega mu by sigma. If I can write like this one, dear students, omega mu, like previous one, where is that? Omega mu sigma divided by sigma square I can write, because in numerator this epsilon cancel, in numerator sigma is not there. If I write sigma here, square comes, then 1 by root 2 plus j 1 by root 2. So ultimately this becomes eta is equal to omega mu sigma by 2 under root divided by sigma plus j omega mu sigma by 2 divided by sigma. You can write here eta. This is what, student? Omega mu sigma by 2, that is actually 1 by skin depth. Okay, you can see here this is nothing but alpha. Okay, so that alpha is equal to, here you can see alpha is equal to 1 by skin depth. Here this becomes 1 by sigma del plus j 1 by sigma del, that is equal to, this is a plus ja type, this is then root 2 by sigma del and e power j tan inverse b by a, both are equal, you get pi by 4 you get. So this is mod eta and e power j theta eta. So this one is for a good conductor, this equation is valid. That means modulus of eta is root 2 by sigma del, theta eta is pi by 4. Here, for a good conductor, everything is calculated in terms of skin depth. First calculation will be skin depth, that is skin depth is equal to 1 by root pi of mu sigma. Once if you calculate that, then alpha is equal to 1 by skin depth, beta is equal to 1 by skin depth. If you want eta is equal to root 2 by sigma into skin depth e power j pi by 4. Now everything is calculated in terms of skin depth. Now what is the speciality of this one? Impedance is also complex and real part and imaginary part both are same. That is the speciality of this. So now third one, phase velocity definition is omega by beta. This is general formula, but for good conductor, for good conductor, phase velocity is equal to omega del, omega into skin depth, because beta is equal to 1 by del it becomes. Similarly, what do you say? Lambda is equal to 2 pi by beta. This is general formula. Now, for good conductor, lambda is equal to 2 pi into del it becomes. Okay. Everything is written in terms of skin depth here. Next, other here na alpha is present, beta is present, and modulus of eta is also present, theta eta is present. So electric field, magnetic field, power equations are same as general equations. Okay. Electric field equation in the good conductor is ei0 e power minus alpha z cos of omega t minus beta z, and hy of z comma t is equal to ei0 divided by modulus of eta e power minus alpha z cos of omega t minus beta z minus theta eta. Then average Poynting vector is equal to half into ei0 square divided by modulus of eta e power minus 2 alpha z cos of theta eta az cap watt per meter square. You should understand where alpha is equal to omega mu sigma divided by 2. That is nothing but root pi of mu sigma. Root pi of mu sigma. Next, that is equal to beta. Both are same. Next, mod eta is equal to root 2 by sigma del. And then theta eta is equal to pi by 4. So why I am not putting them in the box, student? Anyway, you know these things already in the box. Now, no need to remember them separately, students. Okay, this is all about wave traveling in the good conductor. So, dear students, now let us write one point here. For uniform plane wave E bar comma H bar values are constant. Constant means actually uniform only. Constant means at every location same value is there. Same means uniform. Now I am explaining you why it is called as uniform plane wave. Actually, wave means electromagnetic wave. Plane means surface. Uniform means constant. So, for uniform plane wave, E bar comma H bar values are constant. Constant means uniform at all locations on a plane. Plane means surface, student. Plane means surface. On a plane, that means surface which is perpendicular to the wave propagation. That is why. I will explain by taking example. For wave traveling in z direction, E of z comma t is equal to ei0 e power minus alpha z cos of omega t minus beta z. So for wave traveling in z direction, on z is equal to constant surface. So wave is traveling in which direction? Z direction. So for example, I will take this as a z direction. Then I will take here z is equal to 1 meter surface. Z is equal to 1 meter surface I will take. So this 1 meter means constant. So that means this z is equal to constant surface is perpendicular to the z direction. Okay, like this the surface. Now I have taken the surface at z is equal to 1 meter. 1 means constant. So this is called z is equal to constant surface. Now this is the wave propagation direction. Now this surface is perpendicular to the wave propagation direction. Now on this surface, what is the value of electric field? Answer, you have to substitute z is equal to 1. You substitute z is equal to 1. Then alpha is always constant. EA0 into e power minus alpha, you get that electric field value is constant. Constant means uniform. So on this plane, which is perpendicular to the wave propagation direction, electric field as well as of course magnetic field also A0 by mod eta e power minus alpha into 1, that is also constant. So that is why it is called uniform plane wave. So here for z is equal to 1 meter plane, plane means surface, which is perpendicular to wave propagation direction, which is perpendicular to wave propagation direction. For z is equal to 1 plane, or otherwise on z is equal to 1 meter plane, electric field magnitude, otherwise electric field value is EA0 into e power minus alpha into 1. It is constant. Constant means uniform. So that is why it is called as uniform plane wave. So for uniform plane wave, electric field and magnetic field values, of course power value also, are constant. That means uniform at all locations on a plane. At any location, z value is 1 only for that. So on a plane, plane means surface which is perpendicular to the wave propagation direction, or otherwise simply wave propagation. You can write here perpendicular to the wave propagation, or otherwise wave propagation direction. Both are correct. Okay. Now let us discuss uniform plane wave and normal. Normal means what, student? 90 degrees. Normal incidence. Normal incidence. Incidence means falling on. Falling on. Incidence means. So uniform plane wave, uniform plane wave and normal incidence. For example, dear students, here there is one surface, let us say like this, one surface. I told you that this surface, from front it looks like a line. Now here this side medium 2 is there, that is wood medium. So for example, here medium 2 is there. Now here one surface is there, that is called boundary surface. This side air medium is there, that is called medium 1, and this is wood medium, that is called medium 2. Here boundary is a surface, whose thickness tends to 0, then that is called boundary surface, or otherwise simply boundary. Now here let us say there is a boundary surface. This is z less than 0 you take, that is medium 1, and this is z is equal to 0 or otherwise xy plane. So this one is z greater than 0, this is medium 2 is there, let us say. Now here for example, there is one antenna which send signal, electromagnetic signal in this direction like this. So now this signal traveling in medium 1 tries to enter into the wood material, that is medium 2, if impedance of this one are not same, then you call that as impedance mismatch. Then some amount of signal is transferred, then some amount of signal is reflected. Now whatever signal coming here, like this EM wave is coming here and hits this boundary at 90 degrees angle, that is called normal incidence. So normal incidence means the EM wave is hitting this boundary surface at 90 degrees angle. How much angle? 90 degrees angle. Now here because of impedance mismatch, some amount of signal is transferred into this medium, like this it is transferred. Some amount of signal is reflected here. Some amount of signal is reflected. So this is called a uniform plane wave. That means this one coming from the transmitting antenna. Here this is a transmitting antenna. Coming from transmitting antenna, traveling in air medium, we are calling that as a medium 1, and trying to enter into the cement wall or otherwise wood material or some other type of material, that is called as a medium 2. Wherever that wood material starts, that is taken as a z is equal to 0 distance. Z0 distance means the wave is ready to enter into the medium 2. That is the meaning. When wave travels 1 centimeter into the medium 2, that is taken as z is equal to 1 centimeter. For example, z is equal to 1 meter means wave traveled into the medium 2 for 1 meter distance. That is the meaning. Z less than 0 means, for example, z is equal to minus 1 centimeter means wave is at wave is behind this boundary at 1 centimeter distance. That is the meaning. So once again, I am briefing now. Uniform plane wave and normal incidence. This is medium 1, this is medium 2, and it is called z is equal to 0 boundary. Now in medium 1, parameters are epsilon 1, mu 1, sigma 1, gamma 1, and eta 1. They are the parameters. You know the formulas. Here epsilon 2, mu 2, sigma 2, gamma 2, eta 2. Similarly, here you will have from gamma 1 is nothing but alpha 1 plus j beta 1. Gamma 2 is nothing but alpha 2 plus j beta 2, like that. So here this is incident wave and this is transmitted wave and this is reflected wave. Now one point we have to remember, incident wave and reflected wave are present in the medium 1. That is why while writing equations of incident wave and reflected wave, you have to use medium 1 parameters. This is transmitted wave. Transmitted wave is in medium 2. While writing the equations of a transmitted wave, you have to use medium 2 parameters. Now I will call this as incident wave. That incident wave has electric field and magnetic field. The electric field of incident wave is called as EI bar, and in phasor domain suffix S is used. The magnetic field of incident wave is HI bar. That means magnetic field of incident wave. In phasor domain means S is used. Similarly, this reflected wave has electric field that is called as ER bar. In steady state or otherwise phasor domain suffix S is used. Similarly, this reflected wave has a magnetic field equation. This is called as HRS. And this is transmitted wave, so that is called as ET bar, and in if you write the equation in steady state suffix S is used. Now here Ht bar, that means a magnetic field equation of transmitted wave in steady state. Here, if you see carefully, this one is a normal unit vector from medium 1 to medium 2. This is medium 1 and this is medium 2. This normal unit vector makes 90 degrees angle with the boundary surface. So that boundary surface is like this. Now this one is like this. It is making 90 degrees angle. Dear students, this incident wave is in the direction of normal unit vector to the boundary. So the angle between incident wave and the normal unit vector is 0. So incident angle is defined like this. Incident angle means the angle between incident wave and normal unit vector to the boundary surface. So now that incident angle is theta I is equal to 0. For example, if this is medium 1, this is medium 2, this is called normal unit vector to this boundary, and if EM wave comes and hits like this at some angle, that is called theta I. So this is EM wave is hitting like this, and it makes so students, this one is boundary surface, this one is normal unit vector. Now EM wave hits like this. Now it is making some angle called theta I with the normal unit vector, that is called incident angle. If this incident angle is 0, then that is called normal incidence, that is hitting 90 degrees. So if this theta I is not equal to 0, theta I is for example 30 degrees, that means theta I is not 0, that is making some angle, that is called oblique incidence. Oblique incidence, we will study that later on. Oblique incidence. Oblique means at some angle. Oblique meaning is, dictionary meaning is at some angle. Normal incidence means theta I is equal to 0. That means that incident wave is not making any angle with the normal unit vector. So that is oblique incidence. We will discuss that later on. Okay. Now, here, what is the discussion? What we are interested in? This incident electric field has EA0 magnitude. Now that magnitude is divided into transmitted electric field magnitude and reflected electric field magnitude. Now we have to get the relation between them in this derivation. So here I am writing I means incident, R means reflected, T means transmitted. Okay. Now let us write the equations in phasor domain. In phasor domain, EI bar in phasor domain is equal to EI0 into e power minus gamma 1 into z ax cap. This is wave traveling in z direction. Similarly, HIS is equal to EI0 divided by eta 1 e power minus gamma 1 into z into ay cap. For wave traveling in z direction, electric field x component is there, then that electric field x component generates magnetic field y component, and electric field divided by eta 1 gives a magnetic field in phasor domain. Now these are incident equations. Similarly, students, E R S, that means reflected electric field equation, magnitude of electric field is ER0 and e power gamma 1 into z ax cap. Dear students, for reflected wave, for incident wave, electric field magnitude is EA0. For reflected wave, electric field magnitude is ER0. And here minus gamma is there. minus gamma z means that wave is traveling in plus z direction, but reflected wave travels in minus z direction. So in the exponential, plus should be there. And also h r s is equal to here er0 divided by this reflected wave is also in medium 1, so that is why you have to use eta 1 only, e power gamma 1 z. Now here ay you are using but you have to use minus ay. You know why you have to use minus ay? I will tell you. For uh, for the here unit vector in power flow direction is equal to unit vector in electric field direction and unit vector in magnetic field direction. So unit vector in electric field direction is ax, unit vector in magnetic field direction is ay. So ax cross ay is az. That means power flow direction is az. So wave is traveling in z direction. Power is also traveling in z direction. That is correct now. Here if I calculate AP is equal to AE cross AH, now electric field is in x direction. If you take magnetic field in y direction, then once again you get AX cross AY is AZ. Now power flow direction is AZ you are getting. If I take plus here, power flow direction is AZ. But wave is traveling in minus Z direction. So wave carries power in minus Z direction. So equations also must tell the power is carried in minus Z direction. So that is why you have to put minus here. So minus here. So minus here. So one conclusion is there, student. For reflected wave, power is carried in reverse direction. For that, either electric field or magnetic field should have opposite sign. That means if my plus is there, here minus should be there. If minus is there, here plus should be there. They should have opposite sign. But in case of incident wave, electric field and magnetic field will have same sign. If it is plus, it is also plus. If it is minus, it is also minus. So that power goes in what do you say, plus z direction. For that, I am putting this in the bracket. This is just observation here. Okay. Now these are the equations. So let us say equation 1, equation 2, equation 3, equation 4. Similarly, for transmitted wave, Et bar is equal to initial value is called Et0, e power, it is traveling in plus z direction. So e power minus gamma into z if wave travels in plus z direction. For medium 2, suffix 2 is taken here. So ax cap, equation number 5. Now HTS, transmitted magnetic field, is equal to ET0 divided by eta 2 because it is in medium 2. So e power minus gamma 2 into z ay cap. This is equation number 6. So these are the equations, dear students. Now you should understand that here electric field has x component, magnetic field has y component. Both x and y components, both x comma y components of the E comma H fields are tangential. Tangential means parallel, students. Tangential means parallel, or tangential to the z is equal to 0 boundary. Z is equal to 0 boundary is nothing but xy boundary. Okay, xy boundary. Now you want relation between fields of medium 1 and fields of medium 2. For that you have to use boundary conditions. So first boundary condition is electric field tangential component in medium 1 at z is equal to 0 boundary is equal to electric field tangential component in medium 2 at z is equal to 0 boundary should be equal, because one boundary condition is tangential component of electric field in medium 1 must be equal to tangential component of electric field in medium 2 at z is equal to 0 boundary. Now what is the electric field, total electric field in medium 1? Total electric field in medium 1 is equal to incident electric field plus reflected electric field, because in medium 1 incident wave is also present, reflected wave is also present. So total electric field in medium 1 is equal to incident electric field plus reflected electric field. So total electric field tangential component in medium 1 at z is equal to 0 boundary is nothing but ei0 e power 0 ax. So that is total electric field in medium 1 means ei bar plus er bar. So plus er0 e power 0 ax, that is equal to, dear students, once again I am telling, total electric field in medium 1 is equal to incident electric field plus reflected electric field. Now at z is equal to 0 boundary, put 0 here, put 0 here. Then x component, electric field has x component. That x component is tangential to z is equal to 0 boundary. So whatever electric field is there, total electric field becomes tangential component. Tangential means parallel. Now in medium 2, only transmitted wave is there. So total electric field is equal to transmitted electric field only. So transmitted electric field is here. If you substitute Z0 here, ET0 into, you get ET naught e power 0 AX, you get now that is equal to EA0 AX gone. So EA0 plus ER0 is equal to ET0. So this is equation number 7. Similarly, third boundary condition. Why are you going for third boundary condition? Because here electric field and magnetic field have only tangential components. So first boundary condition also talks of tangential component. Third boundary condition is also talks of tangential component. So third boundary condition is magnetic field tangential component in medium 1 at z is equal to 0 boundary, at z is equal to 0 boundary is equal to total tangential component of medium 2 at z is equal to 0 boundary. So in medium 1, total magnetic field is incident magnetic field plus reflected magnetic field. So that has y component. That y component is tangential to the z is equal to 0 boundary. So substitute z0 here. That becomes ei0 by eta 1 e power 0 and ay. Next, if you substitute z0 in this, that is er0 divided by eta 1 e power 0 minus ay, that is equal to, in medium 2 total magnetic field is only this one, and if you substitute 0, so et0 divided by eta 2 e power 0 and ay. Now here ay cancel, and then you get minus here. So ultimately this equation becomes ei0 divided by eta 1 minus of er0, here minus comes here, divided by eta 1 is equal to et0 divided by eta 2. So ultimately this is ei0 minus er0, so eta 1, eta 2, so et0, this is equation number 8. Now if you add equation 7 plus 8 implies you get er0 cancel, so 2 ei0 is equal to, and et0 is common, then here 1 is there, 1 plus eta 1 eta 2, so here you get et0 is equal to, this comes this side, 2 times eta 2 divided by eta 1 plus eta 2 ei0. So this is equation number 9. So eta 2, eta 1 plus eta 2 divided by eta 2. So you have to reverse the 2 eta 2 by eta 1 plus eta 2, this one. Now put equation 9, this one, in 7. So there ET0 is here. So EA0 plus ER0 is equal to ET0 is 2 eta 2, eta 1 plus eta 2, EA0. You can send this side. So ultimately you get ER0 is equal to, if you send this one this side, minus 1 comes. So this is minus 1. And then you get eta 2 minus eta 1 divided by eta 1 plus eta 2. So EA0 you get if you send this side. So this is equation number 10. Directly I wrote, students. You have to send this EA0 this side, common that. Then 2 eta 2 divided by eta 1 plus eta 2 minus 1. Then you get eta 2 minus eta 1 divided by eta 1 plus eta 2. So actually, students, here what calculation is going on? There is here incident wave. This incident wave has a EI0 electric field. Now that is splitting into ET0, and that is splitting into, I will write like this. This EI0 electric field is some amount is splitting into ET0, some amount of electric field is splitting into ER0. How much incident electric field is transferred to ET0, and that is called transmission coefficient. It is defined like the transmission coefficient. Then how much of electric field is reflected, ER0, that is defined as capital gamma in Greek letter, and that is defined as reflection coefficient, that is the definition. So these two are defined like that. So ET0 by EA0 is defined as transmission coefficient. ET0 by EA0 is defined as transmission coefficient, symbol is capital T, and ER0 divided by EA0 is defined as capital gamma, that is reflection coefficient. They are definitions actually. For those definitions, we have equations here. We have equations. ET0 by EA0 is defined as transmission coefficient. The equation is 2 eta 2 by eta 1 plus eta 2, and ER0 by EA0 is defined as a reflection coefficient. For that equation is eta 2 minus eta 1 divided by eta 1 plus eta 2. So here, dear students, divide equation 7 with EI0 both sides. Then you get EI0 divided by EA0 plus ER0 divided by EA0 is equal to ET0 divided by EA0. Then this is 1. It is defined as a reflection coefficient. It is defined as transmission coefficient. We will talk of this later on, student. This is equation 11 actually. Okay. So dear students, now definition, reflection coefficient. Symbol is gamma. So reflection coefficient is defined as the ratio of magnitude of reflected electric field and incident electric field. Okay. It is defined as the ratio of magnitude of reflected electric field and incident electric field. This is the statement. Now, mathematically, reflection coefficient is ER0, that is magnitude of reflected electric field, divided by EA0, that is magnitude of incident electric field. So, this is the definition actually. Okay. Now, let us say this is a equation number here. From this, you can see here, from equation 10, ER0 by EA0 is equal to eta 2 minus eta 1 divided by eta 2 plus eta 1, or otherwise eta 1 plus eta 2. Plus is there means you can interchange the position, no problem. Okay. So, this is equation number 12. Put equation 10 in 12, then we get gamma is equal to ER0 divided by EA0, eta 2 minus eta 1, eta 2 plus eta 1. Actually, for example, here eta is equal to j omega mu divided by sigma plus j omega epsilon under root. If sigma 0 and mu r is equal to 1, then what will happen? If sigma 0, then j omega cancel, mu r is equal to 1, then automatically eta is equal to root mu naught mu r is 1. So, mu naught divided by epsilon will be there, epsilon naught epsilon r, that becomes eta naught divided by root epsilon r it becomes. Okay. So, this is eta naught divided by root epsilon r. That means here this ratio, if sigma 1 is equal to 0 and sigma 2 is equal to 0 and mu r1 for first medium, mu r2 for first medium is 1. That means this is lossless, both mediums are lossless mediums and they are non-magnetic mediums. For non-magnetic medium, mu r is equal to 1. For magnetic medium, mu r is greater than 1. So, lossless and non-magnetic mediums, then what will happen? Eta 1 is equal to, here you can see, eta naught divided by root epsilon r1, and eta 2 is equal to eta naught divided by root epsilon r2. If you substitute these equations here, then what will happen? Eta 2 is eta naught divided by root epsilon r2 minus eta 1 is eta naught divided by root epsilon r1 divided by, so here eta 1 plus eta 2, or otherwise eta 2 plus eta 1, ultimately you get this one. Now, take the common factor epsilon, root epsilon r1 and root epsilon r2. What you get? It goes here. Root epsilon r1 minus root epsilon r2 divided by root epsilon r1 plus root epsilon r2. Now, this is the shortcut formula for many questions. So, I am writing the formula here, that gamma is equal to reflection coefficient. Definition is ER0 divided by EA0. This is definition. And after derivation, we got the general formula eta 2 minus eta 1. So, eta 2 plus eta 1. Here we can write eta 1 plus eta 2, or otherwise eta 2 plus eta 1, both are same. Now, this is a general formula. General formula. General formula means what? Applicable for all cases. Medium 1 and medium 2 can be any type of medium, no problem. So, now this formula, you can see here, eta proportional to 1 by root epsilon r. That is why here, if you write in terms of root epsilon r terms, they are interchanged. In place of eta 2, you get root epsilon r1. Here, you get root epsilon r2 divided by root epsilon r1 plus root epsilon R2. So this is the shortcut formula. This is used when both mediums are lossless. That means sigmas are 0 and both mediums are non-magnetic mediums. So for non-magnetic mediums, mu r 1 and mu r2 is equal to 1. Every time in examination, we get questions that both mediums are dielectric mediums. For dielectric mediums, mu r1 and mu r2 will be 1, and the lossless dielectric medium, these are 0, sigma 1 and sigma 2. So whenever these conditions are satisfied, then you have to use this formula, and this is nothing but gamma of electric field I will write. That means reflection coefficients for electric field. You have to put this in the box. Okay, students. So I was doing one derivation. You have seen the derivation, but do not learn the derivation. The first formula which you have to remember in this derivation is this one. Now you have to remember this formula, where gamma E is reflection coefficient of electric fields, reflection coefficient of electric fields. Now, if I write the reflection coefficient of magnetic fields, reflection coefficient of magnetic field is defined as reflected magnetic field divided by incident magnetic field ratio. So now you write this in terms of electric field. HR0 is equal to ER0 divided by eta 1, because reflected wave is in medium 1, and minus sign comes. Why minus sign is coming? For reflected signal, either electric field or magnetic field should have opposite sign. That is why. And here HI0 is EI0 divided by eta 1. Now eta 1 cancel, so you get ER0 divided by EI0, that is equal to minus of gamma E. So dear students, gamma H is equal to simply minus gamma E. Okay, and gamma H is reflection coefficient of magnetic fields. Reflection coefficient of magnetic fields. Okay, now gamma power, so that is nothing but reflected power divided by incident power. I am taking reflected power density divided by incident power density. If you take power densities, then in power densities per meter square cancel, again you get power ratio only. So reflected power is half into ER0 HR0 divided by half into EI0 HI0. Now half cancel, so ER0 divided by EI0 and HR0 divided by HI0. So this ER0 by EI0 is gamma E, and this is gamma H. Now in place of gamma H you can substitute minus gamma E. So I will be writing this formula here. Gamma P is equal to, definition is reflected power divided by incident power, that is equal to reflected power divided by incident power. So you get gamma E multiplied with gamma H. In place of gamma H, if you substitute minus gamma E, then ultimately you get minus of gamma E square. Minus indicates that for reflected signal, power goes in reverse direction. That is the meaning. So I am putting this in the box, dear students. So have you seen the sequence? आप लोग देख रहे हैं sequence को. Only you have to remember this formula. Then no need to remember this gamma H is equal to minus of gamma E. Whatever answer you get, minus of that. Then whatever answer you get gamma E, you take a square of that, put minus, then you get a reflection coefficient of the power. In some books they don't put here minus, no problem. So power reflection coefficient is gamma E square. Minus indicates that reflected signal power goes in reverse direction. That is the meaning of that one. So here gamma P is also called as a fraction of reflected power. Fraction of reflected power means how much power is reflected compared with incident power. So gamma P is called as reflection coefficient of power or fraction of power reflected. Okay. Now percent of fraction of power reflected is equal to gamma P multiplied with 100. Okay, whatever is there here, multiply with 100. Then you get a percent of fraction of power you get. Okay. So here, what do you say? I wrote 3 equations. One is reflection coefficient of electric field. That formula you have to remember. Then reflection coefficient of magnetic field is nothing but minus of reflection coefficient of electric field. Then take the reflection coefficient of electric field, then take square of that, put minus, you get a reflection coefficient of power. Okay. Now transmission coefficient. Symbol is a capital T. Transmission coefficient is defined as the ratio of magnitude of transmitted electric field and incident electric field. That means transmission coefficient is defined as a ratio of magnitude of transmitted electric field divided by incident electric field. This is called transmission coefficient of electric field. Okay. So let us say this is equation number 12 I kept. Now I did not give numbers. So equation number 12. So this is 13. Now here from equation number 9, ET0 divided by EI0. So put equation 9 in 13. Then transmission coefficient of electric field is equal to, definition is ET0 divided by EI0, that is equal to, you get 2 times eta 2 divided by eta 1 plus eta 2. Now this is general. General means general equation. General equation means these mediums can be any type of mediums, but this becomes here root 2 root epsilon r1 divided by root epsilon r2 and root epsilon r1, and this equation is valid once again if sigma 1 is equal to sigma 2 is equal to 0 and mu r1 is equal to mu r2 is equal to 1. Okay, so that means both mediums are lossless and they are non-magnetic mediums. Then this formula is used. Anyway, once again I am telling you, no need to remember this formula also. Why? I will tell you the reason. From equation number 11, you see this EA0 cancel 1. ER0 by EA0 is defined as gamma reflection coefficient. ET0 by EA0 is defined as transmission coefficient. So, equation 11 is 1 plus reflection coefficient is equal to transmission coefficient. If you substitute, what do you say, eta 2 minus eta 1 divided by eta 2 plus eta 1 in this, then transmission coefficient you get 2 eta 2 by eta 1 plus eta 2 you get. So, if you remember this formula, then no need to remember this one. Why you know? In this formula, if you substitute in place of reflection coefficient, you substitute the reflection coefficient of electric field, then automatically you get transmission coefficient of electric field you get. And in this formula, if you substitute reflection coefficient of magnetic field you substitute, then you get transmission coefficient of magnetic field you get. In this formula, if you substitute reflection coefficient of power, then you get transmission coefficient of power. So, now you can observe, overall you have to remember only one equation. What is that equation? Remember gamma E. If you remember gamma E equation, that is first one here, then 1 plus gamma E gives transmission coefficient of electric field. Automatically you get this one, no need to calculate. Then gamma H is equal to minus gamma E. You put that here, you get transmission coefficient of magnetic field. And you take gamma E square and minus gamma E square is gamma P. You put that here, you get transmission coefficient of power, student. So this is important. Here suffix E you put, here also E you have to put. Here H you put suffix, here also TH. Here P, here also P you have to put. Okay, this equation is also important equation. Now, you have written the transmission coefficient of electric field. Anyway, transmission coefficient of magnetic field, transmission coefficient of power, those equations are calculated from this equation only. But anyway, I am writing for your convenience, I am writing those equations also. You can see here, students. Okay. You can see those equations. This is very important equation. Anyway, you can see one observation here, this one. So, if you remember this, no need to remember them, you can observe. Now, I will write transmission coefficient of magnetic field is equal to transmitted magnetic field divided by incident magnetic field. So, that is equal to write transmitted magnetic field in terms of transmitted electric field, that is equal to transmitted electric field by transmitted signal is in medium 2. So, you have to take eta 2 and this one is EI0 divided by incident is in medium 1, dear students. Okay. Now, this is ET0 divided by EI0. So, eta 1 divided by eta 2 you get. What is this ET0 by EI0 is TE and eta 1 by eta 2. So, TH is equal to TE into eta 1 by eta 2. So, here if I give equation number 13, I am giving 14. I am not putting this in the box. That means you need not to remember. ये याद रखने की जरूरत नहीं, आपका मर्जी है, क्योंकि इसमें से आसान से आ जाएगा आपको. Similarly, what is the transmission coefficient of power? That is transmitted power divided by incident power. I will write transmitted power density is equal to half into ET0 into HT0 divided by incident power density is half into EI0 HI0. Then HT0 by ET0 divided by EI0 multiplied with HT0 divided by HI0. Now ET0 divided by EI0. Now this ET0 divided by EI0 here, that is transmission coefficient of electric field. HT0 divided by HI0, HT0 divided by HI0 is transmission coefficient of electric field eta 1 by eta 2. Okay, so transmission coefficient of power is equal to, definition, transmitted power divided by incident power, that is equal to transmitted power divided by incident power, and you get this TE square eta 1 by eta 2, and I am not putting this in the box because from this you will be calculating that one. So this is equation number 15. What is TP here? TP is transmission coefficient of power, or otherwise fraction of power transmitted. Okay, percent of fraction of, this is one point, this is another point, percent of fraction of transmitted power is equal to simply TP multiplied with 100. Anyway, I am not putting them in the box, so just if you know these things, you can, no need to remember this one also, no need to remember this one also. Okay, right, dear students. Now let us talk of standing wave ratio. Standing wave ratio, SWR. Okay, standing wave ratio. Now this is Z is equal to 0, Z greater than 0, it is medium 2, and Z less than 0, it is medium 1. Now in this medium there was incident wave, and out of this transmitted wave, and this is incident wave, and again there was reflected wave here like this. Okay, there was reflected wave here like this. Now this incident wave has electric field EIS. This reflected wave has electric field ERS. Okay. Now what is the total electric field in medium 1? Total electric field in medium 1 is, that is called E1 bar, is equal to EIS plus ERS. So that means it is in phasor domain actually, E1S. E1 means total electric field in medium 1, S means it is in phasor domain. So E1S is equal to EIS is EA0 e power minus gamma 1 into e power minus gamma 1 into Z Ax cap plus this ERS is actually ER0 e power plus gamma 1. Actually, no, both are in medium 1, so gamma 1 is taken. Incident wave is going in plus z direction and reflect wave is going in minus z direction. Okay, so Ax cap. Now, here gamma 1 is nothing but E1s. Gamma 1 is nothing but EA0 e power minus alpha 1 into z e power minus j beta 1 into z Ax cap plus ER0 e power alpha 1 into z e power j beta 1 into z Ax cap. Okay, here I have substituted gamma 1 is alpha 1 plus j beta 1. Gamma 1 as alpha 1 plus j beta 1 is substituted. Let the mediums are lossless, then sigma 1 0, from that we get alpha 1 0, and sigma 2 0, of course from that we get alpha 2 also 0. In general, mediums are lossless. Loss is very less, you can neglect that. That is why we are taking this one. Now here alpha 1 0, here also 0, so this equation becomes like this: E1s is equal to EI0 e power minus j beta 1 z Ax cap plus ER0 e power j beta 1 z Ax cap. Okay, in time domain, in the time domain, this equation becomes E1 for wave traveling in z direction in time domain is equal to real part of E1s multiplied with e power j omega t. So E1 bar of z comma t is equal to here a real part of E1s is this one. You have to multiply that with e power j omega t. So you get EA0 e power, multiply this with e power j omega t, then e power minus j beta 1 into z e power j omega t Ax cap plus ER0 and e power j beta 1 into z e power j omega t Ax cap. Okay, now EI0 real part of this one e power j omega t minus beta 1 z, real part of that one is cos of omega t minus beta 1 z Ax cap plus here ER0 and real part of this one is cos of omega t plus beta 1 into z Ax cap. So what is your observation from this? You have to observe this carefully. In the medium 1, incident wave is also present, reflected wave is also present, and in the medium 1, beta 1 parameter should be used. And also when wave travels from medium 1 to medium 2, frequency does not change. So here also omega, here also omega. In transmitted wave equations also omega should be there. Next, incident wave travels in plus z direction, so inside cos signal or otherwise in the exponential minus should come. Reflected wave travels in minus z direction, that is why in the exponential, there should be a plus. Inside the cos also, for the distance, plus should be there. Now, whenever wave travels, traveling wave means it should be a function of time and distance. Whenever wave travels, then time and distance both change, and this phase also changes, and this phase also changes. But here minus is there, here plus is there. So whenever wave travels, time and distance change. Here time and distance change. This phase having plus, this phase here having minus, they keep changing, but it has different value, it has different value. At some location, at particular time, this phase and this phase become equal. Then in that case, incident wave and reflected wave both are in phase. In phase means same phase. Then in that case, EI0 and ER0 are added up. Then total electric field will have maximum value of the electric field. So maximum value of electric field occurs whenever incident wave and reflected wave are in same phase. Same phase means this phase and this phase will be equal. That will not happen at every location at every time. That happens only particular locations that happens. So at some other locations, if this phase is for example 0, then this phase is 180, then phase difference is 180 minus 0 is 180, then e power j 180, that means e power j pi, you get cos pi plus j sin pi, you get minus 1. In that case, this and this equation and this equation, they are subtracted. So electric field, total electric field becomes EI0 minus ER0. That will be the least value of the electric field. So then other locations, the overall electric field will be between maximum value and minimum value. So dear students, now this is the total electric field equation in the medium 1. So in the transmission lines also, in the transmission line also, total voltage equation will be in this form. Total voltage equation is equal to VI0 cos of omega t minus beta z and plus, and here you will have V R0 cos of omega t plus beta z. Their voltage is not a vector, so that is why direction will not be there here. And in the transmission lines, this is called as a V plus. A symbol is changed. V plus means initial voltage of incident wave, and like this you write cos omega t minus beta z plus this. For reflected wave, no, it travels in reverse direction, minus. V minus means this is the initial voltage of the reflected wave. Minus means the wave traveling in minus z direction. Plus means the wave traveling in plus z direction. That is the meaning. So cos of omega t plus beta z. There also these equations will be similar actually. Okay. Anyway, I am putting this in the box. That is just observation. Now I am giving a equation number, equation 1. Okay. At some locations, at some locations, or otherwise at particular locations, doesn't matter. At some locations, incident comma reflected waves are in phase. That means reflected at some locations, incident comma reflected waves, that means reflected incident and reflected electric fields are in phase. Then the incident comma reflected electric fields are added and gives maximum electric field. Maximum electric field, that is the maximum electric field of total electric field, that is. So here E maximum is equal to EI0 plus ER0, but in here in front of them if minus sign is there, otherwise if they are complex, no, generally mod is taken and then added. Okay, so this is equation number 2. At some other locations, at some other locations, incident comma reflected electric fields are at opposite phase. Opposite phase means plus or minus 180 degrees phase. Then they are subtracted because e power plus minus j pi is equal to minus 1 you get. They are subtracted and gives minimum value of electric field. So from that E minimum is equal to incident electric field magnitude minus reflected electric field magnitude. Mod is taken because anywhere if minus sign is there, that is removed and subtracted. So this is equation number 3. Only at particular location electric field will be maximum. At some other location electric field will be minimum. For example, let us say this is 10 volts, this is 1 volt, then maximum value is 10 volt actually, like this. Maximum value is 10 volt, 10 plus 1 11 volt actually. So here 11 volt will be there. Then 10 minus 11, 10 minus 1 9, then least value will be 9 actually. But in between these locations, the voltage total electric field value, maximum value is 11, minimum value is 9. At these locations, the electric field will be between maximum electric field and minimum electric field. That means total electric field value will be between 11 and 9 it will be. So that is the meaning of that one. So here the standing wave ratio, that means SWR, is defined as ratio of maximum electric field and minimum electric field, or otherwise it is also defined as the ratio of maximum magnetic field and minimum magnetic field. Both give same answer, dear students. So here SWR is defined as E maximum divided by E minimum. That means here EI0 plus ER0 divided by EI0 minus ER0. So you pull out EI0 here and 1 plus ER0 divided by EI0 divided by, here you pull out EI0 and 1 minus ER0 divided by EI0. So this cancel. Now actually reflected electric field by incident electric field is called as a reflection coefficient, but modulus of reflected electric field by modulus of incident electric field is called modulus of reflection coefficient. This cancel. So 1 plus mod gamma, 1 minus mod gamma. So SWR is equal to 1 plus mod gamma divided by 1 minus mod gamma. You cross multiply, no? Here 1 is there. So SWR minus SWR mod gamma is equal to 1 plus mod gamma. You send this side, you send this side. So SWR minus 1 is equal to, you send this side, mod gamma common. So 1 plus SWR you get. That means mod gamma is equal to SWR minus 1, SWR plus 1. So ultimately, students, after this much discussion, what you have to remember, if you want, this is derivation is going on, what you have to remember, you can remember this one and you can remember this one, only two equations. Then after that you remember this equation. SWR is defined as maximum electric field divided by minimum electric field. That is also defined as maximum magnetic field divided by minimum magnetic field. You get same answer again. Then what answer you get? 1 plus mod gamma, 1 minus mod gamma. So this you have to, why I wrote all the things in examination. In any question, if they give E maximum, E minimum, you take this ratio, you get this one. In examination, in any question, if they give H maximum, H minimum, take ratio, you get this one. In examination, modulus of gamma is given. Take this one, you get SWR. Okay. Now here, modulus of gamma is equal to SWR minus 1 divided by SWR plus 1. Okay. Right. Here one observation is there. Given SWR, then you will get magnitude of gamma you get, but you will not get total gamma. Okay, because total gamma will have magnitude as well as angle. Actually here gamma is equal to eta 2 minus eta 1, eta 2 plus eta 1. In general it is complex. Then if it is complex, generally it is complex, student, general case. So it is complex. If it is complex, then reflection coefficient is also complex. Every complex number has magnitude and angle. So e power j theta gamma. That means angle of gamma, that is. So given SWR, then you get only magnitude of gamma, but you cannot get angle, dear students. That's what I want to say. Okay. Then now we will discuss the cases of the medium.